The setup for this problem is pretty simple because we really want you to concentrate on using significant figures. Basically, we have this jar whose mass is 87.61 kilograms. The student knows the mass of the jar, but weighs the jar with some sand in it. The total mass of the jar and the sand turns out to be 546.2075 kilograms. So the question is, what's the mass of the sand? Well, it's pretty easy to set up. The mass of the sand is just going to be the difference between the mass of the jar and the sand and the mass of the jar by itself. So the mass of the sand is 546.2075 kilograms minus 87.61 kilograms. When I put that in a calculator, I get 458.5975 kilograms. That's an answer, but it's not the correct answer because it's not taking into account significant figures. To get the correct answer, we have to worry about those significant figures. All right, when we're adding or subtracting, we use the precision of the numbers in the problem to determine where we're going to round off our answer. What's precision? Well, precision is essentially determined by the number of decimal places. The more decimal places there are, the more precise the number. Well, let's look at these two numbers. The first number, 546.2075, has a 5 in the 10,000ths place. The first decimal place is the tenths place, the next is the hundredths, the next is the thousandths, the 5 then is in the 10,000ths place. Okay? If I look at the second number, however, the second number has a 1 in the hundredths place, and that's as far as it goes. All right? Now, when we're looking at significant figures, we always have to use the number that has the lowest precision. So in this case, we've got to use the number 87.61 as our guide for significant figures. That number goes out to the hundredths place, so our answer can only go out to the hundredths place. So if we look at the answer, 458.5975, there's a 9 in that hundredths place. And according to the rules of significant figures, that's as far as we can go. So we're going to have to drop the 7 and the 5 from the answer. The problem is we have to worry about those numbers we're going to drop. If the very next number that we're going to drop, in this case the 7, if that's 5 or greater, we have to round up. If it's 4 or lower, we don't have to do anything. We just drop the numbers. Well, in this case, I've got a 7 there. That's greater than 5, so I actually have to take my answer and round up. It's no longer 458.59, but it's 458.60. Now, this illustrates a difference between the way chemists look at numbers and the way mathematicians look at numbers. When a chemist looks at a number, he or she knows that there's error associated with that number because that number is probably a measurement. Measurements have errors in them. So when we subtract two measurements, we can't just report any old answer. We have to worry about the precision of each measurement. If I were to report the answer as 458.5975, that's simply too precise for the measurements we originally had. For the measurements we originally had, the proper answer is 458.60 because that follows the rules of significant figures. Also, notice that I report this answer as 458.60. A mathematician could report it as just 458.6. But for chemistry, that would be wrong because that 0 means something. It means there's a significant figure there. That 0 is significant because the answer is precise to the hundredths place. Who cares if that hundredths place turns out to have a 0 in it? The 0 there indicates that it's significant. So it's just as important to a chemist to put a 0 there as any other digit. If the number has significant figures out to the hundredths place, even if those significance figures are 0, they must be reported. So the proper answer is 458.60 kilograms. All right, let's move to the next problem in this example because the next problem illustrates the difference between adding and subtracting and multiplying and dividing. You use two completely different rules for significant figures in these two operations. So let's look at this second example because it shows how to use the rules for significant figures when you're multiplying and dividing. Well, once again, this is a pretty simple example because we want you to concentrate on the rules of significant figures here. We're given a distance of 3.012 miles and a time of 0.430 hours. And we're asked, what's the speed? Well, speed is given by distance divided by time. So if I take the distance, 3.012 miles, and divide by the time, 0.430 hours, I'll get the speed. My calculator says the speed is 7.004651163 miles per hour. Now that number is way too precise. We've got to invoke the rules of significant figures here to figure out where we're going to round this number to. But the rules for significant figures when you're multiplying and dividing are different. When you're multiplying and dividing, you count the number of significant figures to determine where to round. So we don't look at precision anymore. We don't look at the decimal places. We look at the number of significant figures. How many significant figures are in each number? Well, in the first number, 3.012, I have a total of 4 significant figures. All non-zero digits are significant, so the 3, the 1, and the 2 are significant. And that 0 is significant because it's between 2 significant figures. So my first number has 4 significant figures. What about the second number? Well, the second number has 3 significant figures. All non-zero digits are significant, so the 4 and the 3 are significant. And that last 0 is significant. Remember, there are 2 ways for zeros to be significant. They either have to be between 2 significant figures, like we had in the first number, or they have to be both at the end of the number and to the right of the decimal point. That's true for that last 0. It's at the end of the number and to the right of the decimal point. The first 0 in this number isn't significant because it is not at the end of the number and it is not between 2 significant figures. So I've got 3 significant figures in this second number. So in this problem, I have a number with 4 significant figures being divided by a number with 3 significant figures. According to the rule, we report our answer with the same number of significant figures as the least number of significant figures in the problem. So there are 3 significant figures in the second number. That's the fewest number of significant figures. So that's the number of significant figures in our answer. All right? Well, look at what we got. In order to get 3 significant figures, we're going to have to drop the 4651163. And the speed is just 7.00 miles per hour. Once again, both of those zeros are significant because they're at the end of the number and to the right of the decimal. So notice the difference between adding and subtracting and multiplying and dividing. When you're adding and subtracting, you look at the precision of the numbers, and you report your answer to the same precision as the least precise number in the problem. With multiplication and division, it's completely different. You count significant figures, and you report your answer with the same number of significant figures as the number with the least number of significant figures in the problem. Those are the 2 different rules. Keep them straight in your mind, because as you go on to Module 2, you'll be doing problems where you add and subtract and multiply and divide. So you'll have to use both rules.